Harvard astronomer Avi Loeb has long been known for putting forward bold, unconventional ideas about interstellar visitors, and his latest focus, the object known as 3I/Atlas, has once again stirred both fascination and controversy. This object, officially recognized as the third interstellar visitor ever detected passing through our solar system, is moving at extraordinary speed and displays a variety of unusual features. While the overwhelming majority of astronomers consider it to be a naturally occurring comet, likely composed mostly of carbon dioxide ice, Loeb argues that several peculiar characteristics make it worth considering a far more provocative possibility: that 3I/Atlas could be an enormous alien spacecraft, potentially stretching miles across, and possibly even releasing smaller probes or mini-drones as it travels through the inner solar system. Loeb openly acknowledges that the most likely explanation remains that it is a comet of natural origin, but he also maintains that true scientific inquiry demands exploring all possibilities, including the extraordinary ones, especially when faced with anomalies that defy easy explanation. One of the first unusual aspects Loeb emphasizes is the object's trajectory. According to his calculations, 3I/Atlas is traveling on a path that lies within only 5 degrees of the ecliptic plane, the same plane in which the Earth and most planets orbit the Sun. Loeb contends that the probability of a random interstellar object arriving with such precise alignment is only about 0.2%. For him, this raises the question of whether the alignment might reflect intentional navigation rather than mere coincidence. Adding to the intrigue, 3I/Atlas arrived at a moment that allowed it to pass remarkably close to Mars and Jupiter, two planets of immense astrobiological interest to humanity. Loeb calls this a striking example of fine-tuning, because the object's trajectory brings it near worlds where we ourselves might search for signs of life. Earlier in the month, the object passed close enough to Mars that spacecraft orbiting the red planet, specifically those operated by the European Space Agency, were able to capture images of it. It is projected to come within about 33.3 million miles of Jupiter in March 2026, a distance that could potentially allow NASA's Juno spacecraft to intercept or observe its path as well. Loeb argues that these close encounters with scientifically significant planets add yet another layer of curiosity. A comet arriving from interstellar space could certainly pass near these planets by chance, but the precision of the object's journey continues to raise questions in his mind about whether all of this might be by design rather than randomness. Another feature that has drawn scientific attention is that 3I/Atlas appears to have developed a second tail, one that seems to point toward the Sun rather than away from it. Many comets exhibit what is known as an anti-tail, an optical illusion that occurs when our viewpoint on Earth aligns in such a way that certain particles in the comet's dust tail appear to extend toward the Sun. However, Loeb argues that the second tail observed on 3I/Atlas is not merely a geometric trick or a product of perspective. According to him, this anti-tail behaves differently from anything previously documented. Loeb claims that such an anomalous sun-facing tail has never been reported before in solar system comets, making 3I/Atlas an exception to known cometary behavior. In his explanation, Loeb suggests that as the comet sheds material, particularly on the side facing the Sun, the mass loss might be asymmetric enough to allow larger fragments to drift outward in unexpected ways. The result is a tail structure that defies standard models and invites speculation about whether there is something unusual influencing the material flow. Loeb has also attempted to estimate the object's physical dimensions and mass based on its outgassing behavior and the amount of material being released. He calculates that the nucleus must be more than 3.1 miles in diameter, with a total mass exceeding 33 billion tons. This would make 3I/Atlas between 1,000 and 100,000 times more massive than the first interstellar object, Oumuamua, and the second, 2I/Borisov. Such scale leads to another major scientific puzzle. If interstellar space contains such a massive object, why have we not detected far more smaller interstellar bodies? Loeb argues that statistically, there should be vast numbers of 0.1 kilometer-sized interstellar objects, on the order of 100,000 of them, crossing the solar system before anything as huge as 3I/Atlas appeared. The fact that only two smaller interstellar objects were detected before this massive one raises questions about our detection capabilities or the actual distribution of interstellar debris. For Loeb, these statistical inconsistencies add another reason to question the natural explanation. Although scientists counter that detection biases may simply make smaller objects much harder to identify. Another striking anomaly comes from the chemical composition detected in the gas plume surrounding 3I/Atlas. Researchers found extremely high ratios of nickel and iron compared to other solar system comets. This is puzzling because the temperatures at which these comets are normally observed are far too low to vaporize materials that contain nickel and iron. Typically, these elements remain locked inside silicate, sulfide, or metallic grains, which do not sublimate under such conditions. Yet in this case, nickel and iron atoms were found freely floating in the object's coma. An international team of astronomers, in a paper that has not yet undergone peer review, described the phenomenon as extremely puzzling. They emphasize that current models of cometary chemistry do not account for such vaporization at these distances from the sun. Loeb suggests that the presence of these materials could indicate artificially manufactured alloys, although he readily admits this is speculative. Nonetheless, he insists that the unusual chemical signature cannot be dismissed and should motivate deeper investigation. Meanwhile, other researchers examining data from NASA's SphereX mission found that 3I/Atlas coma, essentially the cloud of gas surrounding its nucleus, contains only about 4% water by mass. This is unusually low compared to other comets, which are typically far richer in water ice. Instead, 3I/Atlas appears to be dominated by carbon dioxide gas. Loeb interprets this as another sign of the object's unusual nature, while other scientists argue that such CO2-rich compositions are not unprecedented and may reflect the object's origin in a region of its home solar system where water ice was less abundant and CO2 frost more common. Johns Hopkins University astronomer Carey Lee stated that SphereX's findings actually support the idea that 3I/Atlas is similar to certain solar system comets, particularly those that contain high levels of carbon dioxide. He emphasized that the carbon-rich nature of the object fits comfortably within known variations of cometary chemistry. Another research group proposed that the comet's ices may have been exposed to unusually high levels of cosmic radiation, altering their chemical balance, or that the object could have formed near the carbon dioxide ice line of its original protoplanetary disk, a region where CO2 condenses more readily than water. These factors could naturally account for the observed chemical distribution, without invoking exotic explanations. Despite the disagreements, what is clear is that 3I/Atlas is a scientifically important object that challenges existing models of comet formation, interstellar chemistry, and the frequency of interstellar visitors. While the majority of scientists view its anomalies as exciting opportunities to refine models rather than signs of alien engineering, Loeb believes that the scientific community should remain open to all interpretations. He argues that dismissing unconventional possibilities too quickly undermines scientific curiosity and risks overlooking phenomena that do not neatly fit existing theories. Loeb's critics counter that extraordinary claims require extraordinary evidence, and so far, no observation of 3I/Atlas definitively indicates artificial origin. Many argue that natural explanations, while complex, remain far more likely. As 3I/Atlas continues its journey through the solar system, upcoming observations from spacecraft near Jupiter could provide valuable data. Whether the object ultimately turns out to be an exotic but natural interstellar comet or something far more extraordinary, it represents a rare and precious opportunity to deepen human understanding of the universe. The debate surrounding it underscores not only the limits of current scientific knowledge, but also the enduring human fascination with the unknown, the possibility of alien civilizations, and the mysteries carried by objects that wander between the stars.